Yeah, 46 is not that bad. All right, guys, so we're doing lessons 46 and lessons 47 today. Today has to do with 46 has to do with rates, and your book talks about the relationship between rates, and you need to know that a rate is a ratio of two measures. It's a ratio of two measures. That's what a rate is. Rate equals the ratio of two measures. So you can have things like 65 miles in 1 hour. That's a rate. The rate of speed they were traveling, 65 miles an hour. Or your fuel economy, you get 25 miles per 1 gallon. Okay, this you always see mph for miles per hour. This on the car, when you're going to buy a car, it's mpg, miles per gallon. Or if you're working and you're earning money, you may be earning $12 per 1 hour. That's your rate. Your hourly rate is $12 an hour. So you'll see it written as this, 12 per hour. Okay, that's what we're talking about ratios and rates, according to your book on page 329. Rate is defined, rate which is considered shown by r, small r, like the radius. Rate equals distance over time. That's how you find the rate of something. So with that in mind, let me erase this and we'll go to our first example, which says Arnold, what we do want to remember is, I'll write this for you, rate equals distance over time. Okay, now with that in mind, we'll do this problem. Arnold drove 390 miles, probably distance, right? 390 miles from Los Angeles to Sacramento in 6 hours. The time was 6 hours. What was his average rate of speed? So obviously my average rate of speed, or my rate, is going to be my distance over my time. And then if I do the math here, I'm basically taking 390, dividing it by 6. 6 times 6 is 36. Gives me a 3. Bring down my 0 is 5. 65 times 6 is 390, so I know my answer is correct. Gives me a remainder of 0. So I know that his rate of speed was 65 miles, because remember I was measuring in distance in miles here, per time, which is hours, for 6 hours. So he was averaging 65 miles per hour. And that's how we would do that. Does that make sense? Not hard, pretty easy, right? Okay, let me see if I have enough room to do one more over here. The next problem says, on the 390-mile trip, I don't know if I need this or not, but I'm going to put it up there. On that trip, his car used 15 gallons. So I'm going to put down here 15 gallons. That's what he used. And his car averaged how many miles per gallon for the trip? Well, you know that I would set that up the same way, because I'm looking for a rate, and my rate this time is it's not distance over time, it's actually distance over consumption, over gallons, right? But it's still giving me a rate because it's something over something. In this case, it's going to be miles over gallons. So my answer has to have miles over gallon. Remember, this line here means per, right? That means per. Whenever you see a divisionary line in a rate problem, it means per. So I see your hand, just a minute. So the rate is going to be 390 over 15. This is miles, this is gallons. When I take 390 and divide it by 15, I'm going to get 2 here, gives me 30. That gives me a 9. Bring down my 0. This is going to be 6, because 15 times 6 is 90. Gives me a 0 remainder. So now I'm going to have 26, and then I have my per line, which is miles. So it's 26 miles per gallon. Gallon goes on the bottom. Everybody see that? Pretty simple, right? Good. All right, I'm going to clear that out. Jared was paid $480. Who had a question, by the way? Amanda? Yeah, that's an equivalence. That's considered an equivalent rate. If you put 12 inches over 1 foot, you're saying that there is an equality there there is a relationship of equality between 12 inches and 1 foot. So that's a different kind of a rate, but it is a rate. It's an equivalent rate. So we have $480 for 30 hours. $480 for 30 hours worked. So the obvious question here is how much money is he making per hour? And we know that if he made $480 in 30 hours, that if we set up our problem, we're going to take the $480, scratch that out, divide that by, oh man, by the 30 hours that he worked, and that's going to give me this, 30 divided by 480, probably going to come to 16. That gives me 18 left over. Bring down to 0. 6 times 3 is 18. Yep, 180. So that means he was making $16 an hour. Everybody see how I did that? Okay. Pretty easy stuff, guys. Anybody confused with this, though? All right. So example 4, 5, and 6 are basically the same thing, and so is 7. So I'm not going to bother you with those same type of problems. I am going to move on to another example that talks about the distance of something, and now distance is going to be expressed in this way. Distance is equal to rate times time. Okay, so rate times time is how we get our distance. So Felipe is planning a bicycle tour of the state with some friends. He estimates that they can ride 7 hours each day. So time, I'm going to put down here, here's what I know. Time is going to be 7 hours a day. And average 12 miles per hour. So the rate is going to be 12 miles per hour. How far does Felipe estimate they can ride each day? Well, we know we're looking for our distance, right? How far is distance? And we know that distance equals rate times time. And our rate is 12 miles per hour times our time, which is 7. And we wind up with 7 times 12 being 84. So we're saying that he can cover 84 miles per day by traveling 12 miles an hour for 7 hours, because 12 times 7 is 84. And so our distance equals 84 miles a day. Okay, make sense? Okay, you guys, for your homework, and you can always look back on this tonight if you need to instead of writing it down today, but your homework is going to be the practice set A through G, and you don't have to worry about the written practice for that. Just A through G. You're welcome. All right, now we're going to move into our Power of 10 lesson 47. Lesson 47 is not that difficult either. Hopefully you'll feel that way. Let me clear this. And we're talking about powers of 10. So you know that when we have this, 10 to the second, we're saying, as far as equivalencies go, we're saying that that's 10 times 10. Would you agree? Which equals 100. And isn't it interesting to know that we have 100 that has 2 zeros, and we have an exponent of 2? Okay? So 10 squared is 10 times 10 is 100. An easier way to do this would say I have a 1 with 2 zeros. Right? That's how you can do that. So if I had 10 to the third, shorthand would just say a 1 with 3 zeros. That should be my answer, right? But let's prove it. What's 10 times 10 times 10? Because that's what 10 to the third is, right? 10 times 10 is 100. Times 10 equals 1,000. Which, guess what? 3 zeros. 3 exponent. All right. Oh. So if we had 10 to the 4th, shorthand would be, what do you think? 2, 3, 4 zeros and a comma. That's like saying 10 times 10 times 10 times 10. What's 10 times 10? 100. That takes care of those. What's 10 times 10? 100. Takes care of those. What's 100 times 100? 10,000. It's 1 with 4 zeros. Pretty simple, guys. Are we okay with that? All right. All right, so now we're going to divide the powers of 10. Or actually, we're going to multiply the power. This is where you may want to pay attention. Guys, so now we have this. 10 to the 3rd times 10 to the 3rd. Now listen, we could write this down as 1,000 times 1,000, right? Using our add zeros based on the exponents. But we can also do it this way. We can say 10 to the 3rd times 10 to the 3rd is 10 to the, and then we change this multiplication sign to a plus sign, and we add our exponents, and we get 10 to the 6th. And because if we were to take 1,000 times 1,000, what are we going to get? 1, 2, 3, 4, 5, 6 zeros, right, or a million. 1,000 times 1,000 is a million. We have 6 zeros, which is what we're saying by 10 to the 6th, right? So all we do when we multiply is we keep our base of 10, and we simply add the exponents. So if I had 10 to the 2nd times 10 to the 4th, what is my answer? 10 to the 6th. So that's like saying if we have 100 times 1,000, it's still going to equal a million. Still going to have 6 zeros. Everybody understand that? Okay. I know you've done all this before. I know. All right, guys, now we're going to do division. We have 10 to the 6th divided by 10 to the 3rd. You can't use calculators to give you your answer, so the easiest way to learn to do this is when we have division, just like when we had multiplication. Remember, we turned the sign so it was a plus sign? Well, here we get rid of the little dots and we subtract. So this is going to be to stay as a base of 10, but now we're just going to subtract the exponents. 3 from 6 is 3. So that gives us 10 to the 3rd. That is our answer. Now, if you wanted to take 1 million and divide that by 1,000, you could. Okay? And here again, this is a different problem. When you're dividing these, what you're doing is saying, I'm getting rid of these zeros, so I have to get rid of these zeros. You're left with this. And what is 1,000? How do I write that as an exponent? 10 to the 3rd, which is what we said our answer was, right? You see how that works? Nice and convenient, huh? So guys, here are some rules. These are the rules of exponents. Put it in our fancy little box here, and hopefully I can write it in here now. The one thing then, recapping, we said if we take a to the x times a to the y, we end up with a to the x plus y. Okay? And then also, if we take, I'm not going to have enough room in this box, a to the x divided by a to the y, our answer is going to be a to the x minus y. Then and our last one is going to be, if we have, we didn't do this yet, but if we have a to the x to the y, then we wind up with that equals a to the x times the y. Okay, that's in your book. You'll want to remember that, commit that to memory. That's something you'll want to know. Okay, so let me erase this, go to an example that I have for you. If we take 2 to the 4th times 2 to the second. Amanda, what would my answer be? What is it? 2 to the eighth. Anybody agree with that or disagree? You all think it's 2 to the eighth? You add. You don't multiply. Remember I said you change this to a plus sign. It's 2 to the sixth. It's 2 to the sixth. You understand that? Because you do. Because if you were to take, well, because it's your base. It's your base number, so your base stays the same. Yep. Yep. Well, because here's the thing. If you take, look at it, if you take 2 times 2 times 2 times 2 times 2 times 2, you get 2 times 2 is 4 times 2 times 2 is 8 times 2 is 16. 2 times 2 is 4. 16 times 4 is what? 64? Okay, so if you take 2 times 2 times 2 times 2 times 2 times 2, what do you get? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Get the same answer. So you just say 2 times. You keep your base stays the same. Okay, yes. What is that? Yeah, Tanisha. The answer is 2 to the sixth. When you're doing this, 2 to the fourth times 2 to the second, the base stays the same and we add our exponents because we're multiplying. London? Yeah. Right, right. So Tanisha, let me ask you, if I had 2 to the fourth times 2, or I'm sorry, duh, hold on. 2 to the fourth divided by 2 to the second, what's my answer? 2 to the second. I'm dividing. Okay, look at what's 2 times 2 times 2 times 2? 16. And divided by 4 equals 4. And what's 2 to the second? 4. Okay? Make sense, guys? All right. Now here's our next one. 2 to the fourth squared equals 2 to the what? No, remember I said, remember when you have a times x to the y, it equals a times xy. So you're multiplying this, be 2 to the eighth, right? Because what you're doing is, look, you're taking 2 times 2 times 2 times 2, and you're doing that twice, times 2 times 2 times 2 times 2. So you're multiplying 2 8 times, so you just say it there shorthand. Because you do what's in here first, then you got to do it again. Order of operation is inside parentheses, and then you do it again. So you can just, to save a shorthand, is just to multiply, because this is the rule. This is the rule. When you have parentheses, ax, close parentheses, to the y, the answer is ax times y. So we take our x and our y, 4 times 2 is 8, 2 to the 8th. The same thing as saying this right here. Does that make sense? If it doesn't, you get to do some of these for homework tonight, so it's not that bad. Now, we also want to be able to write this in expanded notation. So we have something like this, 5,206. We want to write that in expanded notation. So it's going to start with 5 times 10 to the what? What column is this in? It's in 1,000, so we need a 3 here. Give us 10 to the 3 is 1,000, right? Plus 2 times 10 to the plus. I didn't cover this, but it's 10 to the 0 for the ones column. That should be you. Okay. For the ones column, it's 10 to the 0. 10 to the 0. 6 times 10 to the 0. No, because when you have no, it's not because what you're saying here. How many zeros do we have? We have 0, so it's written as 6 times 1. Remember, the exponent tells us how many zeros we have, right? So 10 to the 0, we have 0, so that 0 goes away. It's 6 times 1 is 6. Make sense? Does that make sense, guys? Okay. All right, let me ask you one more. Let's say that we have 3.5 what? Okay. Divided by 10, you in a hurry? 3.5 divided by 10 to the 4th power. So let's think about this. Let's write this in long form. That would be like saying 3.5 divided by 10,000, right? Now, we can go through the process of adding a bunch of zeros here to make this work, right? But also, would you agree that when I'm dividing, I'm making my original number, which is this number right here, when I divide, I'm making that number smaller. Does that make sense? Does anybody not understand that? When I multiply it, I'm making it a bigger number. I'm multiplying, right? Okay, so if we know I'm making this number smaller and we're adding zeros, that's all we're doing, then I'm just moving it over that many decimal places to make it a smaller number. So I take my 3.5 and I have 4 spaces, I have 4 zeros, so I'm going to move it over 4 spots. There's 1, there's 2, there's 3, there's 4. So my new answer becomes 0.00035. That's what I get for my answer. That 3.5 times 10 to the 4th is this, 0.00035. And without even doing anything, guys, when I see 10 to the 4th in division, I just know wherever my decimal's at, I'm just going over 4 places. 1, 2, 3, 4. And I'll put my 0 there. That's all I'm doing when I have division like this. I just move it over because I'm making this number smaller. I'm dividing by this big, huge number. It's going to make this number smaller. Right? Now, if I was multiplying 3.5 times 10 to the 4th, I'm increasing that. I'm multiplying 3.5 times 10,000. It's going to give me a huge number. All I can do is go this way. So I go over 4 places this way. And when I do that, I wind up with 3, and then I have a 5. That's 1. There's 2. There's 3. And there's 4. So my answer becomes 35,000. Okay, big number. Does that make sense? Okay. No? Who said no? Who didn't get it? It's all right. Tanisha, you need help? Huh? Guys, listen, I'm not talking to you. I'm talking to Tanisha. It wasn't Tanisha? Who was it? Julia? Are you sure, Julia? Don't succumb to the peer pressure. If you don't understand, let me know. Now you understand? Which one didn't you understand? This one or this one? A or B? Which one didn't you understand? A or B? Okay, well good, you can do this next one for me since you understand it. Okay, Julia, I have 2.76 and I'm going to multiply that by, or no. I'm going to divide that by 10 to the 2nd. What's my answer, Julia? Which way do I move it? Okay, so there's once, and then there's twice right there, right? So I got to put a 0 right there. So is that my answer, Julia? 2.76. 2.76 divided by 10, my answer is going to be 0.0276. Okay, because if I go back 2 places to the other way, I get back to my original number, right? That's how I can check it. Is everybody okay with all that? All right. Yeah. Yep. Yep. 276 10,000ths. Yep. It'd be 276 10,000ths. All right, guys. We're going to end this thing.